Alright, hello everyone, welcome to the first lecture for Golang from the Code the Universe Foundation. I am the lecturer Aditya Dewalker, and we're going to go ahead and get started with learning about Golang. So before we get into any code examples, I want to talk about really quickly what is Golang and what is it good for. So Golang is a language made by Google. It was released in about 2008, so it's about 12 years old, which is a relatively new language. It has very similar syntax to languages like Python and similar languages, except it also introduces the speed of languages that are actually compiled to languages like Python or not Python, sorry, C and C++ and whatnot. So essentially, it's a language that's used for mostly server architectures, so back-end architectures. This is like things like APIs and WebSockets and things that you would connect to. Go is extremely good at making parallel code work. And when I say parallel code, I mean code that will run at the same time concurrently. If that information went over your head, do not worry about it. It is very trivial. We'll get more into it as we go with Golang. We're first going to get an introduction into the language and how as a language it works, and then we can go ahead and get started. So we can get into more advanced topics regarding how Go is a great language. So to start, we're going to go ahead and actually learn about the first part of Golang, and this is going to be the project structure, actually the file structure. So for any language, there's going to be a certain way of setting up your program. For Python, for example, there is no setup for your language, right? However, for Golang, you're actually going to set up your language. So in the case you're working with, something like you're working on a browser, what we're going to do is we're going to first use something called REPL.it. So I can actually minimize this and then go here, and I can open a new tab here. I'll close this here. I can open a new tab, and I can type in REPL.it. This URL here, repl.it, and we're gonna hit start coding, or you can hit sign up. If you hit sign up, on the next page there'll be a new REPL button, and it'll take you to this page. We're gonna go ahead and scroll down, or you can just type it in, and we can type in Golang. So if we type in Go, and the language is actually called Go, we're calling it Golang here because it's easier to find when you're searching on a search engine, for example, because Go is a very ambiguous term. So Golang is used to refer to the programming thing. So when we hit create REPL, it's going to create a REPL here. It's going to open some files. You can actually collapse this side here by doing that. You can switch to dark mode by using this. And then you have a terminal to the right. And then you have this code automatically generated for you. And then you also have a play button right here. And if you run this code, it's going to print out hello world. So that's how you set up your Go project on REPL. If you're using a actual project manager and you're actually working on your computer, then in that case, reach out to a teaching assistant or a teacher or myself, and we can get you help. We can get you some help in regards to actually setting it up on your computer. However, moving forward, we're just going to use REPL for the sake of this, just in case people are joining from a Chromebook or something. The project structure in Go can be a little more complex than other languages. So we're going to go ahead and just maximize this once again, and we're going to get started. So the first thing I want to get into is I want to learn how to how that hello world program from a couple seconds ago worked. So what we're going to do is we're going to go through setting up that program, and we're going to talk about the individual parts. So first I'm going to type in something called package main. So what this does, it's our first line of program. And I'm going to make this a little bit bigger so that you guys can see it. So we're going to make this font size, we're going to do it large, or huge actually could work. And hopefully you guys can see that. Okay? So we're going to type in package main. And package main essentially will call this package that we're working on the main package. So we can only run the main package. If you want to run a package that's not called main, you'll have to actually import that package into a package which has the main attribute. So for the sake of this, ignore that, and we just type in package main. This is the main package. It's how we identify this is the first package we're going to run. Okay. And then every program, it's similar to how C++ has int main. Every program in Go is going to have a function, which is defined like this, main, and then some curly brackets, just like that. So what this does, it's going to say, this is the function, it's called main, and this is the entry point into the language, into the program. So if we run this code, for example, we can run this code here, and it's not going to do anything, right? It's going to call main, and that's it. And I can type anything here. It won't do anything to the program. The program is executed successfully. So in order to print hello world, we actually are going to, in Python, to print hello world, you type something like this, hello, world, just like that. And, in Python, you just run this code and it would run. So in Golang, it does run. However, That's because the Golang print, this actually has a print statement. However, for the sake of logging purposes and getting into future topics, this hello is actually not what the print statement that we want to use. Rather, we're going to use something called the FMT package. So we're going to do import FMT. So when we import FMT, we're basically saying that, hey, Golang, I want you to import some package, some other package. And the package that we're specifically talking about right here is the FMT package. And the FMT package is actually just called the format package. And if you're wondering what this is a comment. If you do a double /, any of this code after it's not going to be executed. This is just a note to the programmers that look at your code that this is a comment, and you can describe things here. So this is a format package. So what we're going to do is, rather than doing print like this, to have a little bit more power, and this is going to be for future proofing, and when we get into more advanced topics, what we're going to use, we're actually going to go down here, and we're going to say FMT. Actually, I'll just delete this line, and we can do it from scratch, okay? So we're going to do FMT, and then we're going to put a dot, okay? So essentially what we're doing here is we're calling the FMT package, which we've declared here, and we're saying, down here, I want you to use the FMT package, and I want to use a function that's defined in this FMT package. And the function we want to use is going to be print line. So print line is basically going to print onto the terminal, and it's going to print a new line after that. So we're going to type in hello world, because that's the most simple example we can do. And when we run this, it's just going to print out hello world and then a new line. So it's going to terminate this line, it's to print out hello world, it'll terminate, and it's not onto the next bracket. Once again, you could ignore what we just did with print. Print is basically a built-in language function, but there are some flaws with it. And generally speaking, to get into more complex topics, we're going to go ahead and use, fmt.println, just like this. Okay? So that's something that you can do with printing. So next I want to go ahead and get into some similar printing topics. So what we can do, for example, is we can actually replace this code with, let's say, let's do a more concrete example. So I'm going to type in fmt.println. I'm retyping it for the sake of this. And I can type in something like my age is. Okay? And this is going to say my age is. So if I run this code, obviously it's not going to do much. It's just going to say my age is. And you could have predicted that. I can type in my age is 17. When I hit run, once again, it's also going to say my age is 17. Okay? But what I want to teach you guys about is something called string concatenation, which is one way that we can do formatting strings. So rather than doing 17, what we can try to do is we can type in 17 like that. So we're going to say my age is, and then we're going to add an integer, which is my age, because that's how old I am, right? And ages are integers, typically. When we run this code, we're going to get a quick issue. And we're going to say, it's going to say invalid operation, my age is 17, age is, and then plus 17. Mismatched types, untyped string and untyped int. So what this means is that we're having an issue somehow adding my age is and then the number is 17. So what we can do instead is we can do the same thing. I'm going to remove this here. And actually, I'm going to keep this, sorry. And then we can do is we can close this by quotes. And that way it's going to add a string to another string. And this is going to be similar to other languages where you have to add strings. You're not allowed to add numbers and strings and numbers. So here you see, it correctly prints out my age is 17, which is a, pretty rudimentary stuff. We're obviously adding, and this is the same thing as basically saying my age is 17. That's exactly what this interprets to when you add it. So the reason I brought this up is actually we're going to do something a little bit more complex, and this is how you typically will format strings when you do things in this language. So what we're going to do is we're going to try to do something called a string substitution. Okay. And so this is one way you can format strings, and what we're going to do is we're actually going to type in, I'll remove this code here, so just like that. And then it says my age is. So after the my age is, rather than putting 17, I can actually just say %d. So when I put %d and I type in comma 17, what we'll see is that this should print out my age is %d, and this is just going to be in the end. So if I run this code, it's going to print out that. It's a little bit weird, and why did it print out like that? We want to put 17 into the %d. So first off, I have to ask you guys, what is this %d doing? The %d is for the sake of basically doing a string substitution. So it's going to say it's a placeholder, so some digit, and that's why it's a d here. Right? If we want to do a string, we could do s. But for the sake of this, we're going to do %d. So it's going to basically ask this function that, hey, you'll eventually get a value for this, but this is currently a placeholder. And then you can put as many numbers as you want here, for every %d that you have. However, we have one issue here. It's not actually running because currently we're using the basic print line command. What we can change is we can type in the printf command. Printf means print format. So when we run this code, you'll notice it actually prints out my age is 17. Okay? So this is one of the basic examples. And then what we can do is now to terminate into the next line, we can type a /n. And this will print out onto the next line. Like so. If we run this code, we'll be on the next line. So we can copy this code like this. And then we can run this multiple times. I just, pasted that multiple times. And it'll say, my age is 17 with a new line in between. Okay? So similarly, I can type in next year. And after this next year I will be. And then I can put another %d. If I run this code, we're going to get an error. And this error is that they're missing. Right? It says missing value. Because we haven't actually supplied a value here. So what we'll do is we can put 18 here. Because next year I will be 18. And now you'll see that it's no longer missing and it's printing out the next thing like that. So this is one way that we can do string formatting. And this is the typical way that you'll see string formatting being done, is using this %d and %s's and f's and whatnot. So if we wanted to actually put in %s, we could say, right here, I can remove this. And I can say my name is, and then %s. And then by using a %s, we can type in my name as a string over here. That's going to be substituted back into here. So when I run this code, it's going to substitute it automatically for us, just like that. So we can go ahead and move on. This is basically how you do some string formatting. We're going to get into more complex topics with string formatting later. It's something really useful to know when you're moving on and you're doing more complicated topics, how to do some string formatting topics. So what we can do is we can remove this code here. And what we're going to do is we're going to first start with some basic math operations. So what we're going to do is we're going to first start with the 4 basic math operators, which is plus, minus, times, and divide. So we can type in a print line statement because this is very simple. We don't need to use a printf. So we're going to use 4 plus 4, 8. We can type in 4 times 4, 16. 4 minus 4, that's 0. And then lastly, of course, 4 divided by 4, that's 1. So if we run this code, just like any other language, it's going to run normally, 8, 16, 0, and 1 as we expected, right? So this is how you do the basic print operations. We also have another more complicated operator, which is called a modulus operator. So modulus operator. A modulus operator basically finds the remainder of 2 numbers when divided. So an explanation for that is when you divide 20 by 5, the answer is obviously going to be 4, right? When you divide 23 divided by 5, the answer is going to be 4.6, okay? Now that's how how we've been told to interpret division. That's technically, correct, that 20 to 5 goes into 23 4.6 times. The alternative approach is that 23 divided by 5 is actually, it goes in 4 times with 3 remaining. And this 3 is actually, a modulus operator would yield 3. So the modulus operator is actually going to yield us a value of 3. It's going to find us the remainder when 2 numbers are modulated. So, or when 2 numbers are divided, sorry. So if I print out fmt.println, and then 23 mod 5, and that's how that's pronounced, it's mod 5. It's a % though, that we're using. So I'll just put that up there, the %. When I run this code, you'll notice this value is going to be 3 because this is going to be that. And something I can do to make this a little bit more intuitive is actually one of the features of the print statement here is that you can actually say, addition of, you can say 4 plus 4 is. If you put a comma in between, it's going to automatically concatenate the strings, which means it's going to add them together. So if I run this code here, the first line will show you 4 plus 4 is 8. And then I can do the same thing for these guys down here. So this is the times, this is the minus, this is the divide. Run this code there, that will work. And then similarly, I can replace this code here. So 23 mod 5 is 23 mod 5, and this will yield the value. So run this code, it's going to print out successfully that, 23 mod 5 is 3. And this is another string formatting technique. A lot of string formatting, a lot of print formatting things can be very complicated. It's a very huge topic that you can get into. It's a more complex topic, but it's definitely pretty important. So what I want you guys to do is I want you to do your first task. It's gonna be task 1.1, and I'm actually gonna use another type of comment. So we're gonna use these types of comments. So these types of comments basically are block comments, meaning anything between these comments, these symbols are commented. So just like that, right? So anything between the symbols are comments. So basically, I'm going to use that for this next topic. And typically, conventionally, you put an asterisk here. However, that's completely up to you. If you want to put an asterisk there, I'm going to put an asterisk for the sake of convention. But we're going to write our first task, which is task 1.1. And I want to use, do some math operations. And how are we going to do these math operations? First, I want you to multiply a number by 7. Then, and pick whatever number you want. We're going to subtract by 4. And then we're going to do, let's say, I don't know, divide by 3. And then add 16. And make sure you guys follow PEMDAS when you're doing this. PEMDAS being, you have to, not PEMDAS. Make sure you correctly do these step by step. So multiply by 7, then subtract by 4, then divide by 3, and add 16. I want you to do this in one line of code. But you need to make sure that, you're first multiplying by 7, rather than first adding 16 and then multiplying by 7, because, the order actually matters. So I'll do an example real quick. Let's say 4 times 7 equals 28. And then 28 minus 4 equals 24. Divide that by 3, you'll get 8. And then 8 plus 16 is 24. So our final answer is going to be 24 here. And then our last step I want you guys to do is I want you to mod by 10. So we're going to do 24 mod 10. That's going to equal 4 because 10 goes into 24 2 times, and there's 4 remaining. So we're going to have an answer of 4 here. So I want you guys to write that in code. I'll give you about 3 to 4 minutes. I'll wait until about the 20-minute mark on this video, and then we can continue moving on and actually show a live solve of this question. So if you guys have any questions, obviously, any more in-depth questions, you can contact someone in the Discord if you need help about understanding this question. But essentially, I'm asking you guys just to do a quick math problem and print that out. So yeah, go ahead and do it, and I'll stop you guys in about 3 minutes, and we can get moving on. So I've given you about 3 or so minutes, sorry. And so we're going to go ahead and do a live solve real quick. So basically, what we're doing is we're taking some number, and remember, I just chose 4 in this example. If you chose 4, you could have just gotten the same answer as me. And I'll solve this for 4, and I can show you with other numbers as well. So what we're going to do is we're first going to write out a print line statement, just for the sake of being able to show the code. And then what we're going to do is actually we're going to need a couple sets of braces. And this is because if I do 4 times 7, and then I subtract, minus 4, and then divide it by 3, and then add 16, and then mod by 10. If I run this code, we're not going to get 4, and if we do, it's going to be a stroke of luck. We get 33, which is definitely not the right answer, right? And also I'm going to add the task answer was, and we're going to run this again. It'll show you, we can do some string concatenation like that. Just like that. So, the task answer was 33, and obviously this is incorrect. So what we need to do is we actually need to surround everything in braces. So what we're going to do is we're going to surround this set in braces. So if I surround this in braces, we're going to do 4 times 7 and then minus everything. And then we're going to move on and surround this in braces. And then after the divide, we're going to surround that in braces. After the addition, we're going to do that in braces. And then finally, this is actually not needed. We could do another set of braces, but since this is the last operation, it doesn't matter. If I run this code now, we're going to get 4. The task answer was 4. And if I change this to any other number, like 5, for example, you'll get a similar number. The task answer was 6. I'm not sure if that's correct, but yeah. And actually, it's not correct. And that's going to be a little bit of a... There's going to be a little bit of a reason for that. But, we're gonna move on, actually, because it's a little bit extraneous to what we're going to talk about. And, we can get into more complicated topics about how that works. And I'll explain that why. So if we do 5 times 7, it's going to be 35. And then 35 minus 4 is 31. And then we're going to have an issue here. When we do 31 over this, it's going to be 10.333. And that's going to be right here, 10.333. Imagine that repeating. It's going to be, 26.333. And then 26.333 to mod 10 is actually going to be 6.333. But due to how this works, and due to these all being integers, it's actually going to result us in only seeing 6.333. So that's just one thing to note. And as a test, we can also just try to do this. If I run this code, we might get a different answer, and it's going to say operator undefined on type float, and that's because there's a little bit of nuances that you have to worry about when you do floats. And a float is just a floating point number, essentially just a decimal number that has decimals on the end. So we're just going to run this code. It does work. It just shows us 6 instead of 3, and it is good nonetheless. Okay, so we're going to move on. It's taking a little bit to run, but we're going to go ahead and move on to the next section. So task 1.2 was designed in the lecture plan and the lecture notes. It's actually just the same thing as this, except you add on the mod by 10. So we're going to go ahead and ignore it. And we're going to move on to actually something new. So we're going to talk about variables. So variables are, and I'm going to use this. Variables are used to store data in a representative, I guess I want to say, symbol. For example, in math, you'll see variables stored as, you'll see, x equals 5, x being a variable. So we've all been introduced into, basic variables, at least in the past, and nothing doing really complicated with variables. It's basically used to store some type of value, an integer, a string, whatever it might be, and we're storing something in that variable by virtue of using this type of variable representation. So what we can do is we can go ahead and say something like, to define a variable, let's say the variable I want to define is I, the letter I. So let's say I can do var I int. So what this does, it's going to say, this is a variable keyword, and a keyword is basically something that you would use to prefix a statement to do something. So for example, we have a keyword here, func. That's a func keyword. It basically says the next line of code, the next segment is basically the name of a function, and it's a function. For here, it basically says, hey, this is a variable, and it needs this type of syntax. So basically, we say var, which means variable, which is a keyword. We say the name of the variable. This could be anything. It could be, my age, or in Golang, the convention is my age, and this is called camel case. But regardless, we're just gonna use I for now. And this last part is gonna be int, which is int or integer. Basically, what this means is it's a number. It's a number representation of what we're trying to do. So it's 1, 2, 3, -5, -6. It's any number inclusive of 0, negative, or positive. So then once we have a variable defined, what we can do is we can actually say, we can set the value of the variable to be something. So we can say I equals 50. So we can say, the value of I is, and then I can say, I, just like that. And basically, rather than typing in 50 here, I could do that. I could type in 50 myself. I was declared but not used. So that's another thing about Golang. Golang requires you to use a variable. So if I could remove that code, but for the sake of this, I'm just going to show you. If I do that, and I run this code, we're going to see the value of I was 50, and that is 50, and that's because we're defining the variable up here, then using the variable here. So why is this useful? Well, here's a very basic example. If I copy this code 4 times like that, and I run this code, it's going to say the value of I was 50, and it's going to say it 4 times. Rather than changing the value of 50 here in every single one of these, because I could have say 50 in every single one, like this. I could say 50 like that. Rather, I'm going to keep saying I, and I can just change it once to 45. Now when I run this code, all 4 of the statements are going to be different. And so this is useful if you're going to use a lot of the same, if you're going to use the same number, the same value in multiple places, you can use a variable instead to reduce on code repetition. Rather than typing in the string hello world 50 times, you can just say one variable is hello world, and then you can use it as many times as you want throughout your code, as long as it stays within scope. And within scope just means within your program's the site of your program. And we'll get into more topics about scopes in the future. So if we run this code once again, I change it back to 50, and it's going to print out the value of I as 50. So we're going to delete 3 of these. It's not necessary. And we're going to go ahead and actually do something called an inline definition. So this is an inline definition. So this was a declaration, and then this was a assignment. It was a assignment. So basically, I has the value of 50. I takes on the value of 50, and this is declaring the variable into memory, saying the variable I exists and it's an integer, so please define it as an integer. So down here we're going to do an inline definition. So rather than doing a declaration and an assignment separately, what we can do is we can do var I int just like before. And for the sake of this, I'm going to do var j int, so I can keep my variable separate. And then I can do var j int, and that's my line of code on line 46. That's var j int. What I can do here is I can type in j equals 50. However, that takes up another line. Rather, I can do something called an inline definition, which is equals 50, just like that. And if I print line that, we're going to see, we're going to say the value of j is, and then we're going to type, we're going to run that code, and it's going to say the value of j is 50. And to make it look different, we're going to type in 100. And when we run this code, it's going to say the value of j is 100, which is, what we expect, okay? So this is one method. So this is one method of defining variables. There's a second method, and this is the method that I prefer, and a lot of developers prefer this. So second method. And what we can do with the second method is basically, rather than using the var keyword, we're going to use something called a shorthand assignment operator, and that's a lot of words. But essentially, we're going to use the following syntax. So let's say we want to define some variable, and after j comes k, so we're going to use the value k, or the variable name k, and we're going to say k. So the typical way of doing this is to say var k int equals 25. So rather than doing that, what we can do is, as an alternative, is we can say k, and then use this symbol. So what this says is it's basically saying that k is going to be equal to 25, and this colon equal sign is essentially an assignment operator. So basically, it looks like a whale sometimes. There's been several interpretations of what it looks like. It looks like a creeper from the Minecraft video game, whatever it may look like to you. It's an equal sign with a colon before it, and basically what that does, it's going to show that this is an assignment operator, and we want to assign the value of 25 to k. Now here's one caveat: we're no longer declaring the type, right? Like in this code, and I'll do this code just to make it clear. In this code here, we're declaring the type of variable that there was. Using this, we're asking Golang or Go to interpret dynamically. So we're interpreting the value of 25, and we're saying, hey, this is a string, an integer, a Boolean is a true or false value. And we see that's an integer. The compiler will see it as an integer. And so we're going to say that k is now equal to 25. So if I copy this code here, I can change j to k, like that. And I run this code, and we see that now the value of k is 25. So this is another way of defining a variable, unlike var j int and the var I int, This is another way of defining it. It's a lot shorter than before. So now let's say we want to change the value. And remember, we could change the value over here. And let's say I equals, let's say 75 now. We could copy this here, and we could say the new value is 75. And that's going to print out accordingly. The new value of I is 75. So similarly, we could do the same thing here. And we could print out a new value there. So even though it's an inline definition, it's going to work the same. Now here's the issue. And it's not really an issue. It may seem pretty intuitive, but there is a small difference here. And so in the case when we're working in an assignment operator, what's going to happen is that we're not going to use this colon equal sign if it's not defining a new variable. So to put that into some code, basically when we want to change the value of 25, this is not going to work. So if we put this here, I'm going to delete this line. And if we put this line here and we say the new value of k, we're going to get into a syntax error, actually an error. And it's going to say no new variables of left side colon equals. And it's going to point out what line it happened on. It's going to say line 55, and then this is a character. So we're going to go on line 55 and say 1, 2, 3, 4, 5. So this is the operator that the issue occurred on. This basically is saying no new variables on the left side of the colon equals, and of the assignment operator. And this basically means that there's nothing on the left side that's new. We have k is 25 here, and this time it was new because k was never defined before. However, now we're trying to redefine k to a new value. So what we can do instead is we can use the same method like this before without using a colon, and this can actually change the value of k. So now when we see this, the new value of k is 50, is properly printed out. So you don't use this colon equals unless you're defining and declaring a new variable. If you're redefining a variable, then you're just going to go ahead and use the equal sign rather. So that's one way, that's one caveat that you need, that might be important. So we're going to go ahead and do another task, and this is going to be, I'm going to copy the task from above, actually. So this is task 2.1, do some math operations, and we're going to say multiply the number by 7, etc., etc. So we're going to replace this with 4, and I'm going to replace the code, the math from here. So we're going to have this math from before, and we're going to say with variables now. So rather than using like a multiply by 7 and subtract by 4 and this messy syntax that we have above, what we're either going to do is we're actually going to say, let's just use variable names instead. And let's use a variable and then keep redefining that variable multiple times and do all these operations on them until we get to an answer. So yeah, and basically one thing I want to note is you are allowed to do this. So let's say k equals 50. I'm actually allowed to say k equals 50 plus 25. And then when I print out this line again, and actually, you know what? That's actually a bad example because obviously 50 plus 25 a value which is 75. I meant k plus 25. So it's going to take the value, or let's do 33. So it's going to take the value of k before, and it's going to take the new value of k and add 33 and then assign it to itself. So if I run this code, we should print out, the code is, the new value of k is, here it is, my bad. It's going to print out 58. So because it's saying, take the value of k, add 33 on top of it, assign it to k, and then there you go, that's your answer. So basically we're going to use this principle and concept into using this math here. Remember, we have the math operations defined above. So you have to use these math operations plus this math operation. Using a variable this time instead. So I'll give you approximately 5 minutes until this video timestamp hits about 40 minutes. And make sure you use a variable instead, not the number. And you can actually use multiple lines now to make your code cleaner. So rather than doing this, this mess, we can actually do some cleaner code, and then you can print that value out when you get to the end. If you need help, obviously just keep watching until that 40-minute mark. We have about 4.5 minutes, and I'll go ahead and do a live solve. So in the meanwhile, go ahead and try to complete this problem. so we're going to go ahead and move on. And we're going to show you how to do this code. So what I'm going to say is I'm going to define a variable x. And you can do this either way. You can do var x int, or you can just do x equals and then your number. So let's say my number is 4, like the example above. So what I'm going to do is first I want to say x equals x times 7. Because this is the first step of our task. We want to multiply by 7. Once we do that, if we wanted to, we can actually print this out real quick. We can print this out. And, the value of the task was, the task answer was, just to keep it consistent. If I run this code, it's going to say 28 as expected. Right, so the rest of it, pretty intuitive. X minus 4 equals x divided by 3, x equals x plus 16, and then x equals x mod 10. Just like that. If we run this code now, we're going to see the new value of the answer is 4, just like before, right? So one thing we can change, and this is exactly how a good solution will look. And this is exactly what I was looking for when you're doing the solution. Looks a lot cleaner, than before. This is a pretty big mess compared to this code, which looks pretty easy to read. So one thing I want to introduce you to is actually something called a complex operator. So since we're doing x equals x times 7, another way we can write this is x times equals 7. So what this does, and I can delete the rest of this code. Actually, I'll comment it out. Keep this commented in, and then put this here. So what this does is calls out a variable 4, defines it at x, then we multiply x by itself times 7. So we take the number x itself and multiply by 7. That's what this complex operator does. We put it times and then equal sign. So rather than writing x equals x times 7. This is a simpler way of doing that. So if we run this code, we're going to see this should be 28 as expected. And we can go ahead and move that down once again, and we can say, for this one, x minus equals 4. And then similarly, we can do here, x divided equals 3. Similarly, we can do x plus equals 16. And then similarly down here, we can do x mod equals 10. Now, if we run this code, and we're going to get the task answer, and I'll just remove this to make it look simpler. And this looks very neat compared to our old code, and we still get the same answer. So this is what a complex operator is. It's basically just, whatever operator you want to do, as long as it's a, x times something, and you're using its own value, its own previous value in an operation, you can just use these, this asterisk, the minus sign, the slash, the plus, or the mod, and you can go ahead and do that. So that's one method of basically doing a mathematical operation. So yeah, and it's a lot simpler and a lot prettier than before. So generally speaking, and since this is a more complex programming language, we're going to move a little bit faster through a lot of the concepts. So now we're going to go ahead and start talking about if statements and whatnot. So in Golang, actually, typically in a normal programming language class, I, as a personal teacher, would actually teach you guys about how to take input from the user. In Golang, you typically won't be taking input from the user anyways, plus the methodology for taking input in Golang is actually pretty difficult. You can go ahead and Google it if you'd like to learn. It's actually, once you copy and paste some code and figure out some things, it's pretty easy. But for the case of this, we're going to, stick to the basics and just go about the next few topics, and we'll teach you how to take input and, do more complex stuff a little bit later in the future. So what we can go ahead and now do is we can actually get into something called a conditional. So essentially what a conditional is basically a methodology of basically saying, making a decision based off some lines of code, okay? So what I first want to introduce you to is what is this value is true. So what value is true? What am I talking about here, right? So what I'm showing you guys is the two inherent types of how computers work. It's zeros or ones, right? A zero is, a bit. A one could be a bit. And that's how binary works, binary being zeros or ones. So what we have is basically a true or false value, a positive or negative value. A negative being 0, positive being 1, true being 1, false being 0, etc. So what I want to show you is when we print out this, and I want to do print line. When I type this out and I hit run, it's going to say the value of true is true. And that seems pretty intuitive. Obviously, the value of true is true. But notice, I'm not enclosing this in braces. If I did this, it would print the same thing. But that's actually not the same thing when we're doing some operations with this. When I type in true itself, it still prints out true because true actually has some type of value. And I can do the same thing with false. If I do this and I say false, I can do that. I hit run this code. It says the value of false is false. And obviously that makes sense. And what am I trying to get at? Well, let me introduce you to something similar. This is true. So let's say print line, this evaluates to true. So rather than saying, explicitly what is true or what is false, I can say something that evaluates to true. So what is something that's obviously true that you know? Okay? 1 is equal to 0. Wait, sorry. 1 is equal to 1. My bad. 1 is equal to 1. That's obviously something you know. So if we type in 1 equals 1, and notice I'm using double equal signs here. I'm not using a single equal sign. A single equal sign would basically say, and this is actually going to give us an error. It's going to try to assign 1 equal to 1, and it's going to give us a compiler exit, and then we'll have an error on line 78, which is this one. So we use 2 equal signs, and 2 equal signs is a comparison operator, and basically it's comparing the number 1 to another number 1. So if I run this code here, it'll go ahead and show this evaluates to true, and it says 1 equals 1. And to get rid of the double spaces, I'll just go ahead and do that. So this evaluates to true. So let me do something that evaluates to false. And notice, I'm not actually typing in true here, but it evaluated to true. And this is the same true as before. So if I actually did this, I could also do this. It's a little bit more complicated. But if I ran this, and I had, 1 equals 1, equals true, it says obviously it's true. And if I did the same thing, I could say, what if it's false? What if I try to say it's false? I'm trying to say 1 equals 1 is false. However, that's not correct. And that's why it prints out here, this evaluates to false. So similarly, I could do the same thing here. 1 equals 0, and that's obviously untrue. So if I run this code, now this also evaluates to false. So let me fix these. And if I run this code, it's going to evaluate obviously to false and false. Because 1 equals 1 is true, and true is not equal to false. Because I can replace it with true, it's not equal to false. And similarly, 1 equals 0 is not true. So it'll also evaluate to false. So what are we going to do with this? Why is this useful to us? What did I just teach you? Did I just waste your time for about 7 minutes right there? So what we can go ahead and actually talk about is we can use these in if statement conditional. So basically what we're going to do is we're going to take an if statement. So if, right? In the real world, you could say, if something happens, you do something. If something else happens, you do something, right? So you make decisions every day, and that's how you go ahead and take some conditional statement saying, if I get good grades, I'll get into college, or if I work hard, I'll earn more money, or, however it might be, or if I dedicate myself to learning programming, I'll learn programming, which is exactly what Code the Universe is trying to do, right? So we're making if statements, and we're using a condition to evaluate something that could happen. So in the case of something like an if statement, what we can do is we can actually say if, and then we can provide a conditional statement. So this is right here will be a conditional statement. And then we'll put some code here that will, run, let's say, congrats, this was true, success. So basically what this is doing, and I wrote a lot of code right there, but basically what this says is we're taking an if statement, and this is what that if keyword does here. We're going to take some conditional statement, which I'll define in a second, and then we're going to type in, in these braces, if this is true, if this evaluates to true, this is what we're going to run. So this conditional statement will always be a Boolean, and keep in mind, this 1 equals 1 or 1 equals 0, it's always going to evaluate into that Boolean state because it's a comparison. So what we could do is we could say, in here, we could actually just say true. So if this is true, it's going to print out congrats, this was true. So if I run this code, congrats, this was true. So similarly, if I could say if false, we're now going to see that this code actually won't run anymore because if false, it's not going to run. So another case of this is basically rather than saying true explicitly, we could say if 5 was equal to 5, right? Like how we said this was true before, this should evaluate to true. And if I run this code, that's correct because 5 equals 5. So now what if I wanted to do something more complex? What if it's not what if it's not true? What do I have a catch-all? So what I could do is I can also write on the same line. Keep in mind, if I try to write this code here, an else statement basically says, if something happens, do this, else, do this. So basically it separates the two. And so now if the first statement doesn't actually evaluate, now this is onto this next statement. So onto this else statement, what we're going to say is basically, let's say, I don't know, fmt.println, this was false, and then a sad emoji, or sad emoticon. So if we're trying to run this code, we're going to get an error. And this error is syntax error. So it's going to say on line 84, we have a syntax error. And that's because in Golang, it's very strict on how you place your code in certain locations. We're not allowed to put our code here. Rather, we have to put our code on the previous line on this, where this bracket ends. And we can run it like this in a little sandwich, right, of brackets. And if I run this code now, it will run successfully. It's going to say, congrats, this was true. If I say if 5 equals 6, then it's going to say, this is false. And it's going to give us, uh-oh, this is false. Okay? So, that's one thing that we can do. And basically, how that interprets itself is basically saying, if 5 equals 6, well, this is obviously not true. So this code won't run. Rather, it's going to go down to the next line. It's going to say, 5 wasn't equal to 6. What do we do if 5 wasn't equal to 6? We're going to move down to this else statement. It's an else. Like, what happens if it's false, right? So that's where we're going to get into an else statement. We're going to say, uh-oh, this was false. Okay? So now what I want to get into real quick is basically, I want to introduce all the comparison operators to you. So I'm going to write this code out here. So I'll type in the comment block, just like that. And for the sake of this, since I want to type this out quickly, I'm not going to put the asterisk, but you can. It's conventional. And I'm going to put this code here. So this is some code I've written beforehand. And I'll go over this real quick so it's not that confusing. So we've already gone over, and I'll put this here. We've already gone over this symbol, the equals sign, and that's, over here. It's basically evaluating whether the left side and the right side is equal to each other. So for example, this is true. So I'll indent that this is true. Then we have a not equal to sign, which basically says, it says true if the left and the right aren't equal to each other. So if I say 5 equals 5, this is false. But if I say 5, let me fix that. If I said 5 equals 6, this is true. And sorry, I'm not using equals, I need to use not equals to. Like this. So this has is backwards to this operation, right? Because this would say, 5 equals 6, false. So it's backward to this operation, and basically trying to look for not equal to. Then we also have a greater than symbol. So for example, this is pretty similar. 5 is 5 greater than 4. This is true. Is 5 greater than 5? This is false. And it's false because they're the same value. Okay. So basically, it's a pretty intuitive operator. Similarly, we have less than. So is 5 less than 6? That's true. Is 6 less than 6? That's false. Now you're wondering, these are the same values. Why is this false? This is the same values. Why is it false? What we can do is we also have a greater than or equal to. So this is a greater than symbol and then an equal sign. And what we can say here is basically, let's say 5 is greater than 6. Obviously, this is true. And then also, 5 is greater than 5. 5 is greater than equal to, sorry. 5 is greater than equal to. Make sure you remember those specifics. 5. And this is also true because they're also equal to each other. And similarly, I can say, 5 is less than or equal to 6. Or 6 is less than or equal to 5. This is true. And then 6 is less than or equal to 6. This is true. And this is actually untrue. No, my bad. Okay, so this is a fixed solution, sorry, my bad. This basically says that for greater than or equal to, 6 is greater than 5, which is obviously true. And this is 5 is equal to or greater than 5, which is also true. And then we have the same code here. 5 is less than 6, so this is true. And 6 is less than or equal to 6, which is also true, because of this equal sign. So that's a little bit of the operators. So what we can do now is we can actually implement a little bit of some if statements. So what I'm going to do here is I'm going to, rather than using 5 equals 6 within this actual if statement, what I can do instead is I'm going to actually say, what I'll do is I can define as a variable instead. So let's say define as a variable y, actually b. So I'm going to define some variable b, and we're going to say b is equal to 25, and this is, the full assignment, right? So b is now has a value of 25. So what I want to do is I want to make an if, else if, and then if. So what I can do here, and I'll explain that in a second, if b is at 25, fmd to print line. Actually, I'll do a more concrete example. So let's just say income equals 20,000. So let's say your income is 20,000, okay? So if income equals, or let's say if income is greater than 20,000, Then let's say, fmt.println, we can say some statement here. Oh, you make too much to qualify for aid. Okay? What we can do here is then after that, if we can do this, and then we can say, oh, you qualify for some welfare. And I'll say here also welfare. So basically we can, write this code there. And basically what's going to happen is it takes this value to income. And it says, if income is greater than 20, if this income is set to 20,000, if it's greater than 20,000, you make too much to qualify. Otherwise, you do qualify. So this is actually a concrete example of using some code to figure something out. And it says, oh, you qualify for student welfare. Now, similarly, what we can do is we could say, let's say you don't qualify for welfare. And what we're going to do is we can actually say, we can flip this actually. So what we can do is put this here, move this if statement here, move this one down. So now, if income is less than 20,000, we qualify for welfare. Otherwise, you make too much. So let's say this is, and it's refreshing. 1 second. A REPL periodically likes to refresh. Not entirely sure why, but here we go. Okay. So we can say that, if income is less than 20,000, then you qualify. And it didn't save that work. So then if income is less than 20,000, you qualify. Otherwise, you don't. So if we say income is 19,500, and we run this code, now we see at the bottom, it says, oh, you qualify for some welfare. Okay, well, this is great, but let's take the example that you don't qualify for some welfare. What if you qualify for a little bit of welfare, but you don't qualify for the normal amount of welfare? Well, let's see how we can fix that. So in Golang, we also have we have another if operator called an else if. So here we have a catch-all. So else will basically take any value that doesn't get caught by this. So 20,000, it will be caught by this. 19,999, it will be caught by this. So this is taking on any value that doesn't get caught by these. So what we're going to do is what we can say is we can define another else if statement. So how do you write that? We're going to say else if, like this. And then we're going to write our finishing bracket there. So I'll explain this real quick. So basically, rather than having an else statement, we have an else if. So an else if was going to take on another condition, but it's only going to run if your first bracket didn't finish. So if I write some condition here, so this is once again a conditional statement. So now I can write income less than 40,000. I can write here, oh, you don't qualify for welfare, but you may qualify for some aid. Just like that. If I write this code now, and this is still one line 1,000 or 100, it just wrapping it. So if I write this code, else if income is less than 40,000, it's still going to print out, oh, you may qualify for some welfare, but you don't qualify for aid. So if I run this code now and hit play, since I have 19,500, it's going to put me in this first category and run none of the remaining code. But if I put in some value like 20,000, let's say $28,000, and I run this code, now it's going to get caught by the middle section, and it's going to say, oh, you don't qualify for welfare, but you may qualify for some aid, which is very, very helpful. Now we've built a little system that, first takes if income is less than 20,000. Well, our income wasn't less than 20,000, so we don't qualify for full welfare. However, our income is still less than 40,000, so we can qualify for some aid. And finally, if neither of those conditions are met, let's say we make 41,000 in the big leagues now, right? We say, uh-oh, you make too much to qualify for welfare, so we don't qualify for either program, right? So this is a very intuitive way to think about that using this code, and we're using now else ifs and greater than, we still make less than or greater than signs, and we're using those in practice here. So next I want to go ahead and actually talk about a little bit of a task for you guys. So I'm going to copy the task from before. And rather than doing this task, I'm going to actually make a new task. So task 3.1. I believe it's 3.1. I'm not entirely sure. What we're going to talk about is we're going to talk about making a weather or a coat app. Okay. So basically, we're going to see whether or not you want to wear a coat based on the weather. So let's say take the weather from a static or from a variable you define. If the temperature is greater than 60 degrees, then I want to go ahead and if the temperature is greater than 60 days, I want to go, wear a scarf. if the temperature is less than 60 degrees, then I want to go ahead and wear a coat. And actually, sorry, if it's equal to, that's what I meant to say here. So if it's equal to 60 degrees, you're going to wear a scarf. If it's less than 60 degrees, you're going to wear a coat. If the temperature is greater than 60 degrees, wear a shirt. So there's multiple ways to approach this question. So first of all, we're just going to define a variable. Let's say some variable, and you're going to put whatever value you want. Let's say 45 degrees is the weather. Today, for me, it's 83 degrees right now. So let's just say I'm putting 83, because it's May. So we're going to put weather is 83, and you're going to make some logic. And I'll give you a couple minutes. We're going to give you some logic. You're going to make some logic. Basically says, if you're going to wear a shirt, if you're going to wear a sweater or a coat, or if you're just going to wear a scarf. I don't know how realistic this example is, but you can go ahead and figure this out. There's multiple ways to do it, so there's no technical wrong way to do it. So go ahead, take a couple minutes. I'll give you until about 65 minutes on this video's timestamp to finish this part, and then we can go over it in a live solve. So take your time. If you have any questions, obviously ask in the Discord server. So I think it's been a little bit of time, so we're going to go ahead and get started. And obviously, you could have skipped to this point if you finish early. But basically, we're going to go ahead and say if weather. And we're going to use an if statement, obviously, and we're going to do a comparison using the weather variable. So what we can do here is we're asking if the weather is greater than 60 degrees, I want you to wear a shirt. So we're going to say, fmt.println, oh, the temperature is high, you can just wear a shirt. And then our second operator and our second, question is else if, whether, let's say equals 60. So if the weather equals 60, then we want to say, fmt.println could be a bit chilly. How about wear a scarf? Wear a scarf. And then finally, we can say an else statement. This is where we get into two questions, right? If weather is greater than 60, that means every value over 60 is knocked out. Meaning it's already going to be taken by this. If weather equals 60, it's going to be every value that's taken by this. So it's going to be 60, and then everything over 60 is already being handled. So we have two options. If we do else if weather is less than 60, and I I just write my code. Let's see. It's pretty cold today. Wear a coat. So I could write this code, and what now we're doing is 60 is taken, everything less than 60 is taken. That leaves one number, and that's 60, which is also being taken care of. So rather than writing the redundant code, since this takes care of every other value other than 60 and greater than 60, we can just write else. To save on some redundant code, we don't have to write as much code. Looks neater. So now this says that, it's pretty cold today, wear a coat. So if I run this code, it's 83 degrees for me, and it tells me, oh, you can just wear a shirt, right? Now let's say I lived in, Alaska, and it's currently 45 degrees. I'm not sure what temperature it is, but let's say it's 45 degrees. And, it's pretty cold today, you can wear a coat. And if I say exactly 60, we can go ahead and handle that as well. It's going to say, could be a bit chilly, wear a scarf. And this is a really important and pretty fascinating distinction that now we are able to take a Boolean value and do some operations with it to print out, different statements based off a value. And once again, it could be a complicated topic, so if you need more help, obviously feel free, don't hesitate to ask. We'd be more than happy to assist you in understanding these topics more. And if you're not in the Discord server, go ahead and click the link in the description to go ahead and join that. So finally, I'd like to get into some last topics. And we've actually slightly covered this already, but we're going to go ahead and talk about functions. So let's just do a very simple function. And how to define a function is just like before. We've defined a function up here called func main. So func being function, and this is the name of the function. In here, you would put something called parameters, which we'll get into in a second. And then out here, you'll put something about what we're returning. So first of all, let's get into something simpler. What we can do down here is we can type in function, and then we can type in some type of function name. Let's just say, say hello. So if I run this code, this is basically the same way we would define function main, but now we're saying func say hello rather than func main. In func hello, or say hello, I'm going to type in just, print hello, how are you? So this is what this prints out. So if I run this code now, you'll notice nothing actually happens. What we want to do is we're going to call this function like so. So now we can run say hello, and if I run this code, it says hello, how are you? Right? So it's actually going to tell us now about the code that we're writing, and we're able to call this function as many times as we want. So it acts like a variable, and it does whatever task we want in here. So if I want to say Jake says hello, how are you, and then James says I am great, thanks for asking. And now if I want to print this 4 times, if they have repeating conversation, it's going to print out that 4 times. It's great for removing code repetition. If you're doing the same code multiple times over again, you can use a function to simplify that code. So obviously this seems a little bit why are we doing this? Well, what I can tell you is now we can get into something a little bit more complicated. Right? Now let's just do a nuanced example. For the sake of this, we're just going to say I'll delete this code here and I'll delete this code here. Let's just type an example. Let's say we want to make an add function. So we're going to type in func add. and then we're going to write like this. Okay, so this is our function add. So we're going to do return, and then we're going to add two numbers. But what is this return statement? What are we adding? Okay, so how do we pass that on? Well, what we want to do is we actually want to say, we want to add two variables. So we're going to add two inputs to the function, and the function can be passed these two inputs. So how do we take on an input into a function? If we want to say, if we want to be up here, and we want to say, add 3 and 5, we can write the function like this, and this is how we're going to call the function. However, how do we pass these inputs? How do we take this input and actually handle it? Well, what we can do is we can call them some variable. So what we can do is we can type in x, and this is a variable, and then we can type in y. So we're basically going to say, this is x, and then this is y. Now, something important in Golang is when you type in a variable like this for the function, you also have to specify the type. So for this, we're going to specify x int, and then y is also an int. And then down here, we would like to, what we can do first is we can actually say x plus y like that. So we'll print out what x plus y is based off the code here. So if I run this code, it's going to print out 8 at the bottom, just like that. Okay. However, this is kind of useless because now I don't want to print it. I actually want to take the value of x and take the value of this addition and use it somewhere else. So rather than doing that, what I could do is actually I could use a return keyword. And return basically means, hey, this function is going to return something. It's going to return x plus y. So what we can do is we can write exactly that. So we're going to write x plus y. I'll delete that code, and then we can run this. We're going to get into an issue though. It says main.go 126, which is this line here, has too many arguments to return. It has an int that's returning, but it wants nothing to return. And this is because we're not actually telling this function it's going to return anything. We need to actually declare what type it's going to return. So before, it wasn't actually returning anything, so it was okay because we didn't have anything to return before. But now that we have something to return, which is this int, we need to have something to want. So what we can say is this function wants an output of an int. And that's how we write that. It's going to be basically right outside of this parentheses where these parameters are. Right outside, we're going to say int, and this is what's going to be returned. So now if I run this code and run it, you'll notice at the bottom, we don't actually do anything yet. And that's because we haven't done anything from here. However, I can print out the value as if it were just like normal, the value of the function. And I can say, the value of the function, sorry. Oopsies, my bad. Let me fix that real quick. Sorry about that. So I can say down here, the value of from the function is, and then it's going to say add of 3 and 5. And when this interprets, it's going to say the value of the function is 8, as expected. And obviously, if I wanted to use the other type of syntax, just as a reminder, I could do this. I could change it to %d, and then this we can put a /n here, and this would show %d. And this would also work. The value of the function is 8. Pretty simple. For the sake of this, I'm just going to go back because we're getting to some more complex topics in just a second. So yeah, that's how we do that. So let's say we want to do a more complex example. So we've done adding. We could do a subtraction function, which is all the same. We're basically going to take, if we want to do subtraction, we can do, function sub, and then just change this to a minus. That's kind of boring, because especially since this is a useless function, because we already have something that does this. What if we wanted to do something that does all the operators and returns all the operators to us? Or let's just do 3 of them, for example. So we can do a multi-operator like that. It's going to take in 2 variables, the x int and then the y int, which is like, in this example, it's going to be 3 and 5, right? And then what it's going to do is let's say we're going to return x plus y. It's going to return x times y, or x minus y, and then x times y. So now, if we run this code, what we can see is that this is going to return 3 separate values. It's going to x plus y, x minus y, and x times y. If you run this code, you'll notice an issue. And I hope you caught the issue before we even ran this code. So there's 2 issues, actually. One issue is there's this add function no longer exists. So let's change the name of this add function to multi-operator. So if we run this code now, only 1 error exists. And this is too many arguments given. We're basically trying to return 3 separate integers, but we only want 1 integer. So to fix this issue, we basically tell the function that, hey, you're actually going to yield more values than before. So we can say int, like that. So we're going to have 3 ints, int. So what we can do is we can run this code, 1 more error. And this is going to say missing function body. And that's because if we're going to have multiple ints like this, we have to actually enclose them with a parenthesis. So it's going to have just like that. So now if I run this code, it's going to say another error. Okay, and I'm actually trying to get to this because it introduces some errors of how this actually has to be handled. So basically, we're trying to add, we're basically returning these three values into this function and putting this here. However, this is something called a single value context, because println doesn't know how to handle this function when there's a string here. If I remove the string, we can run this code like this. And now this prints out 8, -2, and 15. But what if I wanted to, put my code back here like this? Well, this is a cool part of Golang, and this is an extremely important part of Golang, is I actually need to learn how to unpack values, okay? So remember, this is returning three values, okay? So this is returning addition, subtraction, and multiplication. And this is giving us a value of those three values, and they're three separate values, right? So what we can do is we can define it like a normal variable. Let's say A, B, and C. And typically you do A, B, and C, and then you have your equal sign on all of them. You can say 5, 4, and 3, or whatever. What we can do instead is we can actually say A, comma B, comma C, and define all three variables on one line. And then what we can do is we can say they're equal to 8, 7, and 3, like this. Now will this run? Well, we can test it out. We can put the code here as well, so we can see the values in real time. And you'll notice they do run 873 and 873. They show up, right? Well, this is pretty intuitive because this is exactly what our program returns. The program is going to return three separate values. So now, here comes the question. I'm going to ask this to you. Will this code work? I'm going to add multi-operator here, and I'm going to unpack the values from multi-operator, and I'm going to put them on A, I'm going to put them on B, and I'm going to put them on C. So now, if we run this code, will we get 8, -2, and 15, like intended? And exactly that's what we get, because now we're able to basically take a function and return three values from the function, okay? And we're able to unpack those onto three variables. So now A stores the addition value, B stores the subtraction value, and C stores the multiplication value. And you see that, this 8 is A, this B is -2, and finally the C is 15, which is something extremely important, that we've been able to find through this code. Now, why is this useful? And this is what we're going to get into in future Golang lectures. However, for the sake of this, in the context of this, the importance of what we've just done is actually to discuss and talk about how you can have multiple values coming out of a function. And the most common example of multiple values coming out of a function is actually going to be seen when we do error handling. So let's hypothetically assume some function you write or some function that you're going to use is going to yield an error. And it might yield an error, it may not yield an error. But you want to actually handle the error yourself. So in a lot of the cases, what you're going to do is you're going to have the value of the actual function. So let's do some fake example. So let's say you have some value of the function, and then you have an error of the function. And it's going to equal some function. So you'll call this function, and the function will yield two values. It's going to yield a value, and then it's going to yield an error. If the error exists, then you obviously want to handle that, because then the value isn't going to be correct. But if the value exists, the error won't exist, and then you can go on with that. And that's how you do error handling. And if that went over your head, once again, do not worry. We'll go over that in future lectures. However, I really want you guys to make sure that you understand this multiple context yielding, which basically means, you're yielding multiple values, you're resulting in multiple values from a function. It's one function, but you're able to return three separate values and interpret that correctly. So that's more or less your primary introduction to Golang. We've discussed a lot of things today. We've discussed how to do print statements. We've discussed basic math operations. We've discussed variables and how to define them in two different ways. We've discussed conditionals and if statements, else if statements, etc. And finally, we've just covered functions. And functions are a key component of any programming language to reduce code redundancy, to reduce code repetition, to keep your code as clean as possible. So you can use functions in places where code repeats a lot of the time, and you can use parameters as well to complicate those functions a little bit more. To you reduce your code repetition as much as possible. So once again, I thank you for joining this lecture today. I appreciate you guys for using the Code the Universe Foundation as your footstep into the programming world, especially at least with Golang. And if you guys have any questions, make sure you join the Discord server in the description, or if you're already in the Discord server, feel free to ask questions as you have them. Don't hesitate to ask questions at all. We're here to teach you guys how to program. This is a non-profit for a reason. So with that, I once again thank you for joining the lecture, and I hope you have a great day, a great week, and I hope you stay safe during quarantine. So yeah, and that's all. So have a great day.